Math 20-1, continuing our work with radicals. So in lesson 2.3, you already learned how to add and subtract like radicals and simplify expressions. So this is just really quick. I'm going to splash and dash through just to remind you of what we can do. So with adding and subtracting, we were allowed to collect like radicals if they had the same radical, same radicand, and they had the same index number, right? So in this one, obviously, we've got radicand of 2 and radicand of 5. So when we collect those like radicals together, we get 13 root 5 and minus 4 root 2. These all have different radicands, but we put them in simplest mixed form, and we can collect the root 2's and the root 3's for 3 root 2 and 8 root 3. Finally, we have some mixed radicals, but again, they don't have the same radicand, so we need to put them in simplest mixed form, and when we do, we have a couple of integers and a couple of root 2's, which collects to be 132, 26 root 2. All right, so that was adding and subtracting, and we also did expressions, so we did some more complicated stuff. That was great, and that was your assignment. A little joke along the way, some puns. A shotgun wedding is a case of wife or death. Whoa. What about a man? A man who needs a mistress just to take the break from the monogamy. Just to break the monogamy. If you need somebody to explain that in class tomorrow, just ask. Multiplying radicals. So we need some basic skills. So when you start multiplying radicals, you got to remember some stuff from Math 10. First off, the distributive property. So in the distributive property, you would have learned that 5a plus 4, we need to multiply out. The distributive property says that I will multiply 5 times a and 5 times 4, which gives me 5a plus 20. Can't collect those. The FOIL, a plus 2 times a plus 3 is a squared plus 3. So these are things that I would like you to try and then come back and see if you remember how to do these things, right? We should have kind of done this when we did some factoring and so on, right? But the only thing I want you to remember, there's a shortcut method to this. Nobody really does binomial squares by actually expanding it. Well, we can, but it's certainly much easier to remember this. If I had 2a minus 7 squared, I don't feel like foiling it all out, so I'll just write, oh, that's 4a squared. That's positive 49 because we square the first term, we square the second term, and we multiply the two together and double it. So this is minus 14a times 2, that would be minus 28a, right? Just to clean that up a little bit, this is 4a squared, this is 49, and minus 14a doubled is minus 28a. So there is a quick method to doing binomial squareds, and that's kind of handy as we do some work with radicals, right? For multiplying radicals, those concepts actually kind of help us because when we do simple radicals like 4 root 3 times 2 root 5, we multiply the numbers on the outside together and the numbers on the inside together, provided that they have the same type of radicals. The index numbers are the same, right? So 4 times 2 is 8, and 3 times 5 is 15. Seems straightforward. So in the next example, we've got 5 root 3 times 2 root 3. 10 root 9, but the square root of 9 is 3, so really that's just going to be 30. And as you get better at this, we know that root 3 times root 3, well, when you put that together, that's always going to be just 3. So you can start to maybe skip this step of square root 9 whenever you have a radical multiplied by itself, okay? There'll be shortcuts you can take. In the next example, root 6 times root 6, well, you could have thought of it as root 36, which is 6, but it makes sense. Well, it's just 6. 2 root 5 times 4 root 5 is just 40. Well, how did we do that in one step? Well, because it's really just 8 times 5, right? I'm not going to think of that as root 25. Root 5 times root 5 is just 5. And lastly, 3 root 5 squared, well, 2 squared is 9, and root 5 squared is 5, so that's really just 5 times 9 is 45, right? It's really 9 times 5, which gives you 45, right? So we can start to kind of do these things mentally, right? Hey, so if we continue what we've learned from distributive property, and we just apply that to radicals, and the work we did with just the simple radicals, now we simply have to just consider that, well, in this case, I'm distributing 2 root 3 to both 3 root 2 and 2 root 5. So I simply get 6 root 6 minus 4 root 15. I don't have radicals that are like, and I can't do any more there. In the next question, I have 4 root 3 multiplied into each of those. And so as I multiply both of those by 4 root 3, I end up with 36 minus 8 root 18. Remember that we must always put it in simplest mixed form. So the next step would be to say, well, this is really 36 minus 24 root 2. All right? Distributive property, and then simplify the mixed radicals. If we carry on with binomial multiplication, well, what do we do when we had polynomials, when we had 2 binomials? We had to FOIL. So we need to do the same thing. So now every one of these radical questions is really just going to be 4 little mini multiplication questions, but you got to keep track of this in your head. So if I multiply the first terms, I will get 9 root 10. The next green arrow would be 60. The next the next inside terms would be minus 6 times root 6. So that would be minus 6 root 6. And lastly, you get minus 8 root 15. We look across and now we simplify if we can, and we notice that the only thing I can really do is nothing, right? So that's as simple as that's going to get. There isn't anything to reduce. Lastly, if we carry out the next example, what is 4 root 3 times, 4 root 3 minus 2 root 6 times 5 minus 2 root 3? Again, multiply first terms, inside, outside, and last, right? Or outside, inside, last. We get 4 terms that look like that. And again, we look to see if we can simplify any of the radicals. I can't. Do any radicals collect? No. So that's as good as it's going to get, right? Most questions are going to simplify a bit, right? Oh, sorry folks, I just want to clean up this, so I'll pause. So now we're continuing just like we did with polynomials in math. And what can we do with special products like binomial squareds? Again, we've learned this with polynomials. So if I've got root 3 minus root 2 squared, I simply FOIL it out as though I've got those 2 binomials, and I get 4 terms, which I then simplify to get 5 minus 2 root 6. But a wise mathematician might not do this. They might just use the binomial squared and say, first term squared is just simply 3. Last term squared is simply 2. Multiply the 2 together, that's minus root 6. And if you double that, you get minus 2 root 6. So I didn't bother actually going through all the work of FOIL. I would just say that is, okay, let's do that. So it's going to be 3 plus 2 and minus 2 square root 6. 3 plus 2 is 5. 5 minus 2 root 6. Okay, so if I do the quick way on this one, I would just say, okay, first term squared is 4 times 3, so that's really 12. Last term squared is 9. Put these 2 together, that's 6 root 3, doubled is 12 root 3. So I'm doing some math in my head. 12 plus 9 is 21. 21 plus 12 root 3. Or you can do it the long way, which is multiplying it all out. 2 root 3 plus 3 times itself, get 4 terms, collect them together, and you end up with 21 plus 12 root 3. Either way, depends on which way you like better, okay? The last thing is there's some special terms called conjugates, and boy, are they ever special. They do something really cool. We saw these when we did polynomials, and they were called difference of squares, right? Right. So when you multiply these 2 together, something special happens. Notice 3 root 2 plus root 2, 2 root 3, and 3 root 2 minus 2 root 3. Notice when you multiply them out, you get 18, you get minus 6 root 6 plus 6 root 6 minus 12. The middle terms blow up, and all you get is a rational number. The product of conjugates is always a rational number. In other words, all the radicals blew up. No way. Note that the middle terms always cancel out, and your final answer is something without radicals, a rational number. Okay? That's kind of special. So really all you have to do is just simply multiply the first terms and the last terms. You really don't even need to bother multiplying the middle terms out because they'll always blow up anyway. All right? If you don't believe it, check it out. Okay? So on the next slide, it's asking you, first off, you got to write the conjugate and then multiply it out. Well, what's the conjugate of 3 root 5 plus 2 root 3? Well, that's 3 root 5 minus 2 root 3. I could FOIL it completely out, but I'm not, because I'm only going to multiply the first terms, which is 9 and 5, and the last terms, which would be minus 4 and 3. So I end up with 45 minus 12, which ends up being 33. Okay. And again, if you FOIL it all out, you get the same thing, but I'm only doing firsts and last terms. So the conjugate of 4 root 2 minus root 3 is 4 root 2 plus 3 root 3. If I multiply it out, I'm going to multiply the first, and I'll multiply last. The first terms give me 4 times 4 is 16, and 2 minus 9 and 3, 9 times 3. So I get 32 minus 27, which equals 5. Conjugates give me rational numbers. Last one, 4 root 3 plus 5, which ends up giving me 16. If I multiply first 16 and 3 minus 25 equals 48 minus 25, which results in something like 23. Okay? So that's what conjugates are, and they always multiply to give you a rational number, right? Now your turn, practice these on your own and then come back and look and see what you got. All right? So practice these on your own. Now that you've come back, you end up with 45 minus 12, 33, 32 minus 27 equals 5, and 48 minus 25 equals 23. Okay? And lastly, whoa, what a doozer. But if you've picked up the tricks that we've talked about along the way, this isn't nearly as ominous as it looks, because, and I want you to try it on your own, but try and remember when you approach this question that these are conjugates, so I'll give you a hint. So there's an easy way to do those, and this is a binomial square, BS. All right, so that's a binomial square, so there's a quick way to do that. All right, you give it a try and then come back and look. As I do this question, I would approach it this way. So this is really minus 2 times, in brackets, the two conjugates give me 3 minus 4 times 5. And I'll just stick with that bracket. So that would be minus 2 times 3 minus 20. And that would be minus 2 times minus 17, which in the end would be positive 34. Okay, so all that simplified to that. Plus, the BS, the binomial square. So that's going to be, the first term squared is 4 times 3. The second, or the last term squared, is going to be root 5 squared, which would be positive 5. And in the middle, I'm going to have minus 2 root 15 doubled be minus 4 square root 15. So that binomial squared is all done out. So that would be adding 12 plus 5 is 17 minus 4 root 15, which then equals, so then we're adding this, I can skip down to here, we're adding 17 minus 4 root 15. So in the final answer, 34 plus 17, 41, 51 minus 4 root 15, and all was good. Okay, that is the end of 2.4a, and you can now begin the assignment.